So having someone who has that specialist knowledge helps them to understand their data and actually what it means.
Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Gugan Sanger.
In today's episode of Trend Detection, we will be discussing why data is a very important factor when it comes to your predictive maintenance strategy. I am delighted to be joined by Peter O'Hara, where we're going to be discussing this topic around data. For our audience, if you could start off by introducing yourself, that'd be great.
Peter O'Hara, I am a customer success manager here at Senseye Predictive Maintenance. I've been with the company just over 7 years, and my role in life really is to help customers to use the application to see success, to add more assets, add more users, to just move from site to site until we're basically monitoring everything they've got. It's a fantastic company to work with because our customers have lots of fantastic machines. From we could be making ice creams in the morning or cars in the afternoon or mining. It's just amazing. Lots of different machines, lots of different projects, companies. It's fascinating.
Perfect. Well, thank you so much for joining me on today's episode. Let's get straight into this topic. So my first question to you, Pete, is really around why is data so important in the success of any predictive maintenance strategy?
I think there's two sides to it. The number one is you have to decide why you want to go down a predictive maintenance journey and what are the problems you're trying to solve. And then you have to be able to measure them in order to be able to see whether you're actually being effective in what you're trying to do. So customers will often buy predictive maintenance because they have a particular issue in mind, whether that's too much downtime in their facilities, or if it's not enough operational efficiency, or maybe it's over maintenance, or there's lots of different reasons why people might decide to go down a predictive maintenance journey. And then whatever the reason they decide, that should then lead into deciding on the machines that you're going to monitor and then the data from those machines that will help you to achieve those goals. So the first thing is the overall strategy, and that has to be definitely management-led within an organization, and there has to be buy-in throughout the organization. So you need to have the people who maintain the machines have to agree that these machines will be able to fulfill the goals that you have, whether it's avoiding downtime or reducing maintenance costs or whatever. There's not a lot of point in just picking machines because they have data if those machines will not actually add value to whatever your ultimate goal is.
Okay, fine. And you touched on, just touching back on one of your points you made around, going ahead with predictive maintenance. Could you just cover just a couple points in terms of why companies would choose predictive maintenance and what the main issues are that they're facing?
Yeah, I think a lot of customers will be on a journey, I suppose, from early days. You fix things because they fail, and then you start to plan, okay, well, this failed after 7 months, so I will maintain it after 6 months, and then they will get ingrained into a maintenance strategy that can be perhaps very either reactive to issues, or they're changing things because they've had issues in the past and they don't necessarily understand fully why they're changing parts. So they don't necessarily look at, is this part degrading? Is it near its end of its life? And so you can often over-maintain machines. Whenever you maintain a machine, you always have the issues or potential issues of people not doing things correctly. And so you'll have human error that can cause future machines to fail. So ideally, you only really want to be maintaining machines when they need to be maintained. And then each machine is slightly different because not every machine will have the same workload. Not every machine will have the same weight of tool on it, or the different conveyors might have different weights of product going through. You might be doing a little bit less production at this time of year. And so the maintenance strategy, if it's very fixed, can be overly costly. And if it's just reactive, then your teams are just firefighting all the time, and then you'll always struggle to be that effective and to try and get ahead of the problems and to be a little bit more relaxed and calm in your approach.
Okay. And I guess the other thing, it depends on what industry they are working in as well. You've got different asset types. So it depends on, what issues they're looking to overcome.
Yeah.
I think that's what it is. It's varied over different industries. And the good thing around Senseye Predictive Maintenance is the fact that we can support those industries. It's not just fixed to one type.
Yep. And also, it's not just about looking at your really critical machines. So the beauty of a system like ours is the scalability of it. So you can put lots of very similar machines in there. And so maybe the less critical machines, you can have lots of them there and they're just chugging along and data's coming in and the system's monitoring them and nothing much is changing. Everything just, right, we're cool. You don't have to pay us any attention. And then if there is an issue, you get, whoa, an alert. Oh, okay, I'll go and investigate that, or I'll go and fix that. And things like, we go into an organization and often say you have your big ticket items, right? We want to avoid downtime, for example. So these are the machines that have a lot of downtime. But then you also have other machines that perhaps if they did cause an issue would cause a massive amount of downtime for you, but they're sat there and they don't often fail, and they're really good to put on Senseye as well. Yeah. You're not going to have success with those in the short term. So I'm thinking things like electronic panels. Maybe you've got a load of data going into Senseye, might have 300-400 electronic panels, and they'll just sit there chugging away quite happily. And then one day somebody will maintain the AC and forget to turn it back on. And then all of a sudden you'll have a load of alarms because the things are overheating. Now that doesn't happen often, but when it happens, that's a big issue. And one alert, you say, oh, okay, I'll go and see why that, usually, like I say, either a fan has failed or somebody's forgotten to put it back on after maintenance, and you save a lot of aggravation and everybody's very happy.
Yeah, exactly. And that's the key word. So data.
Yep.
Pete, could you go into just the different types of data?
Yeah, so I suppose there's two main categories. So in the earlier days of Senseye Predictive Maintenance, when we used to like to think of ourselves as data agnostic, data source agnostic. So we will take any data coming in, and we like to harvest data that was existing in the customer's site. So data from their PLCs, from any of their operational technology, bringing that in, maybe tweaking it a little bit to try and remove the impact of different products being produced or different working schedules and that sort of thing. And then using that data, system will automatically learn what is normal, and then it will flag when it's moving away from normal. Now that's fantastic, but part of the problem there is that you need to have, or the customer needs to have, very data literate people within their organization who can harvest that data and then send to our cloud-based solution. So we've had lots of customers who start off with that approach, and then they will occasionally add sensors to critical assets where they want just that little bit more data, that little bit more clarity about what's going on maybe. So that's one approach you can do. You can go from harvesting existing data, cleaning it up a little bit at the customer site, and then sending the data to our cloud. Or you can purchase some sensors and then attach them to the bearings, the motors, that sort of thing that you would like to monitor, and then have that data sent to the cloud as well. Okay. So you can have two approaches. And now for a lot of customers who are not as data mature, we're having more of a pivot where we will say we have a list of suppliers of different price range but good quality like vibration sensors that have an IoT system already proven to connect to our cloud. So the customer can purchase a handful or a number of sensors, and with an IoT infrastructure that maybe it's based on cell phone or cell connection, or it can go through the customer's IT network if they don't mind that. And then you can send it directly to the cloud and the data will just go automatically into Senseye. So you can start really quickly just by putting some sensors on some machines and get data streaming to Senseye really quickly.
Yeah.
And a lot of customers like that approach as well. And then they can look at other ways of connecting up to some of their operational technology to us once they've had that initial burst of getting some good quality, reliable data through other means to us.
Okay, fine. And do you find that a lot of customers who do choose to come on board with us have existing data?
Yes, I think most will. I feel that sometimes they overestimate the quality of their data, because what we would look for in data is data that tells you something about the condition of the machine more than the process that the machine is undertaking. And a lot of customer data is relatively noisy because they don't necessarily filter it for different operations that the machine is undergoing. And if you look at where condition-based monitoring came from, it used to be somebody would walk around a plant with a handheld vibration sensor. They would take readings of the machine. They would have a very nice sensor mounting point where probably the paint chipped off, where they would put their little probe there. The machine would be running at exactly the same speed as it was 3 months ago when they last checked it, and everything is perfect and the data's there. The human will curate it, write a report, and boom, that report goes to the customer's desk.
Yeah.
And some customers think, well, that's what predictive maintenance is. It's a report that I receive with perfect data, and they think they can send any data, whether the machine's on or off, whether it's speeding up or it's slowing down, whether they're changing product types. And there's lots of other things that can have a bigger impact to the signature of the data than the condition of the machine. So what we try and do is to maybe use some contextual data to filter out what the machine is doing, and then pick data from the machine when it's doing a similar thing over a period of weeks and months.
Okay.
So ideally for us, we're not really looking for short-term failures, as in, oh, you better turn that off because otherwise it's going to go bang. We're looking at changes in the signatures of the machines that will give you enough time to actually plan your maintenance, to ideally not have to maintain at the weekends, that sort of thing. You can choose your time when it's most cost effective for you to do it, when your production schedule allows, and that sort of thing. So we're trying to give the customers enough notice that they can plan their maintenance efficiently.
Yeah.
And then that's another way of like driving down operational costs, because you can look at, well, am I using less people at the weekend in overtime? Am I maintaining during the breaks in production where I'm able to plan the maintenance more effectively? People maintaining it will probably be a little bit less stressed because they're not waiting on the machines to, people say, hey, come on, we've got to go back to operations, so they can actually take a little bit more time over their activities, but then they're being more working more safely. They'll have less issues, less likely to make a mistake. So the whole thing will be run a lot more smoothly than when you're firefighting.
Yeah, no, exactly. I think that's what it is. It streamlines the process essentially, and giving the customer that flexibility. So to look into their data, because I feel, maybe something that generally comes up, customers do have existing data, but they don't know the ins and outs of that data. So having someone who has that specialist knowledge helps them to understand their data and actually what it means.
Yeah.
I think that's what it is, which is real key benefit for customers. And then also, like I said before, it links to that flexibility.
Yeah.
So understanding the process from start to finish.
Yeah, and also when we engage with the customer, ideally we'll run through, we have a number of workshops which we will call, we scope out the customer to see where their their areas of concern are and what the machines are going to be, and then we'll dive in with their machine experts as well as our own to understand what the actual issues are with those machines. Because although one of the things that people love us to do is to cookie cutter a solution from one machine to another or one customer to another, you have to make sure that that customer has the same issues.
Yeah.
And you can, even within an organization, when I go in, people say, well, this shop has reduced their downtime by X amount, but we don't have that much downtime. And I've been told I've got to use you. And you're like, well, what problems do you have? And often it's over maintenance. And like I said before, if they will replace something every 6 months because once it failed after 7 and they're too scared to let it run.
Yeah.
But they don't know whether that was just a bad particular item, or if we can see changes in the data towards that 6-7 month, and then I think it is good that you change that component. They change the component, and then the data returns back to its baseline.
Yeah,
you can think, that was good. If you're coming up to the 7 months and the data's not changing, I'm thinking, well, either you're measuring the wrong thing, or that machine isn't actually failing yet. So usually it's the machine not failing yet. So we can help to reduce the maintenance costs by them trusting the data and then pivoting with what they're doing. And I'm not saying the first thing you do after you install our predictive maintenance products is just, all right, okay, we're not going to do anything. But it's just you kind of you might take some of those additional maintenance tasks, those additional checks in particular, particularly the ones where it costs human resources to go around and check things. You can remove those, and then you can free up your maintainers to do other things.
Okay.
And one of the areas we find is that when people start to use our system, their maintenance personnel will have a much further reach within the organization, because they're not just looking after a handful of critical assets.
Yeah.
They're a lot more relaxed about the critical ones, and they're able to look at the other machines, and so they're able to add value.
Yeah.
And so we often see customers, even customers where we've been with since the start, will still add different machines to their fleet of what we're monitoring for them, because it's just, okay, what should we do next? What should we do next? And it's just a continual process of, what's the next low-hanging fruit?
I think that's it. It's this element of excitement as well, because I feel like from a customer perspective, generally I would say customers don't really want to wait. They want to see kind of results as soon as possible. And that's something which seems to just pop up. But just with anything, it does take time. We've got this integral part, which is the data. And in order to see trends and what's going on and when your machine's going to fail, it takes time. But once you start to, I feel, reduce the downtime and save costs, then I feel like from a customer perspective, let's monitor this asset. Let's try this. Let's try this. Because you see the results coming in. So it's just that excitement to see what else they can, use Senseye for.
Yeah, and then the customer will start to think, I wonder what data I can get from that machine in order to monitor it. What are my failure modes? How would that change? And once you get customers thinking like that, it's brilliant, because they're just, I don't know, they're self-perpetuating, I suppose. And each year it's, we'll add this, we'll add that. And then particularly with the cost of the hardware coming down as well, we're now seeing customers in particular that are having to expand some of their operational technology databases and things like that, because we've just got so much data now coming in. They're like, we need to upgrade this, we need to upgrade that. And it's just because they want to monitor more and more. It's really exciting. Yeah,
it is exciting. So Pete, you touched on one of the types of data, which is around contextual data. Could you just give a bit more information about that and what that means?
Yeah, so often it's, what is the machine doing? And often, so one of our first customers, they would be really good at just picking data from their machines that would tell them something about the condition of the machine. So the example I like to give is with a conveyor. So they would, when the conveyor starts up, there's a ramp up in the current, and then after it's running for a while, that current drops off and then it's at a steady state. So what they would do is they would look at the data in quite high frequency, and they would say, okay, in the first 3 minutes, we have a peak of current. So we will capture that as a data point. And then after that first 3 minutes, then we will measure the running current every 5 minutes.
Okay.
And we'll send you the maximum current. And so they would send maybe 2 data points to us, maximum current starting and the running current. And that would be fine. And whenever they started to have issues with the motors or with the bearings, usually it was that peak current that would start to change.
Okay.
And then if they started to see with the running current as well, then they would definitely go and investigate. So that data is very simple, but it's removing any of the context from what the machine is actually doing from the data, and then just sending what we would call a condition indicator.
Okay.
So some customers are not able to do that. So they might send us the same type of data. They might send us current every second, maybe. And then you will then see the data in the application come up and go back down. And so if they can tell us when the machine is turning on and off, that sort of contextual data is really useful. If we're monitoring just something like the current draw and we have vibration, we could perhaps use a current draw to infer the contextual, okay, it's below a certain value, therefore it's off.
Yeah.
So if they're streaming vibration data to us, you can't necessarily tell the machine's off from the low vibration. It might just be running smoothly. But then if the machine's been off for quite a while and they turn it on, then you're going to get a spike in vibration, and that could cause false alerts if the system's got used to the machine being turned off.
Okay.
So the context of is it running or is it not is one thing. Also, customers, they might have different products that have different weights or different viscosities or whatever it is they're making. And so they might want to send us a product code, and that product code is contextual data, and then it will tell the system, okay, analyze this data stream along with the last time we made that product. And so the system will then automatically look at what the data means in the context of what it was doing last time. Okay. So it might be a few weeks ago since you ran that particular product code, but if the data changes quite a lot when you run a different product through your production line, then it just makes the detections more accurate if you can remove the different products from each other.
Okay.
And so you could do that. The customers could do that, what we used to call at the edge, so near the machine, or they could strip out the data, or they send us all the data and they send us the contextual data as well. So what's the machine doing? Things like temperature as well, that can have quite a big effect on the condition of the machine. Often you'll see machines vibrate more when the temperature increases. I've had a customer where they had 2 bearings on their machine, and one was near a wall. It was quite a cold country, and we would find that would vibrate more, and it was because they had the manufacturer's recommended oil, but the oil didn't like the temperature that the machine was in. So one side it was fine, the other side it was got a little bit too cold in the winter there, and so it was having higher vibration because the viscosity of the oil was too high. So they changed it for a lower viscosity oil, and that worked better in their temperature than the manufacturer would have suggested. So the context of temperature, I don't really like temperature too much as a condition indicator from the machine, because once the machine's overheating, it's often a bit too late to start telling customers. But as the context of what's going on in the machine and in the environment, it can be a really good bit of information as well.
Yeah, exactly. And I do feel like contextual data is overlooked. Mm-hmm. It's often overlooked, actually. I think that's something that maybe you could just...
Yeah, I feel that humans are very inclined to filter out things that they don't want to see. We all do it with our our sensors, with sound and sight. There's all sorts of experiments to show that you don't necessarily see everything you think you should see, and we know that we cancel out a lot of noise. And I think it's the same with machine data. Customers will send something, and the data's going up and down, and they say, "Oh yeah, but the failure happened here." But the algorithms aren't going to be able to detect the failure because the data's going all over the place. Whereas if we could normalize that data and then pull out something that is meaningful, not only to the human but to the algorithms, and then they can alert to it. Had a customer a couple of years ago, and they had a motor, 3-phase current, so you have 3 measures of the current coming into the motor. And what they weren't doing was filtering for the off state. And so the machine was often turning on and off, and they were just looking at if the peak current's going up. But one of the legs of the motor began to fail. And so it was dropping out more often than the other 2 that were just dropping on and off when the machine was turned on and off. So that motor began to fail. So they're like, this could happen on any of our motors. It's like, well, all we need to do is look at the difference between the 3 different legs on this current. So you've got 3 readings. They should be the same. If they're not, you've got a problem. So we have a part of our application called derived measures, and you can just manipulate data. Yeah. So very quickly put in a little calculation, what's the difference between these 3 legs of the current, ran it over this motor. You could very clearly see it, and then we just applied it to all their other motors in their facility. Yeah. So they went from a customer who was like, I understand why the system didn't pick up on this because the data's all over the place, but I really want to know about that. And he's like, okay, yeah, you want to know about that? Boom. And then all of a sudden, I'll say within a couple of hours, we could make sure, went back and reprocessed a load of data as well for their motors to make sure the last few months, nothing like that was happening. Yeah. And so they're like, okay, yeah, we're good. We're not going to have this issue again. Yeah. So some of that, they could have thought of that earlier if they had a off-state filter. So we weren't getting the data when it was all 0, then the system would have picked up these drops. But because they weren't filtering, they didn't have the contextual data there, then that bit was missed. But then by saying, well, we will just put in an additional measure that will take that context out, if you like, but then apply it to those motors. It means that they've got another way of monitoring the health of those machines.
Yeah, exactly. It's that education piece again.
Yeah.
Because, like I said, with the platform and how it can monitor assets and different types of assets, it's actually giving the customer that understanding and that education of what's working and what's not working. So then they start to understand, the complexities of some of the challenges that they're facing, but they probably weren't aware of those. Yeah. So it's having a different perspective on how you see your data and how it all just comes together.
Yeah. And I think, and one of the things I like to do with customers is to try to explain to them how the algorithms work, what the algorithms are looking for. Yeah. Because then it means that the customers have a better understanding of what data to feed in. And then, like I say, especially removing some of the noisier data so you can focus in on things that could potentially be issues. I think that's quite important. And again, the contextual data can be really handy there. So again, when we work with our customers initially, we'll run through looking at the machines and then looking at the data, and also finding out what is important to those customers about that data. Because if they don't have particular issues, then you're not going to get a return on investment by trying to monitor those issues.
Yeah. Exactly. I think it's finding the correct way. Or actually, like I said, there's different ways. Yep. But finding the one that's actually going to work for your company and assets that you have.
And their data.
Yeah, exactly.
And like I say, in my mind, it's really easy, but at the same time, I can see it comes across as overly complicated. And what's really nice about the slightly newer approach of putting on vibration sensors into motors and whatnot, is that that's very easy. It's vibrating more, therefore. Whereas perhaps our historical approach of, well, what data do you have? And we will take it from you and we'll make condition indicators and then it will tell you things. That's a little bit of a dark art, I suppose. And so although I still like the dark art side of it, a little bit more straightforward with, okay, you put these sensors on, it will tell you this. Everybody understands, and then you go off and say, oh, you could look at this and you could look at that, and kind of pull them into my way of thinking a little bit more cunningly.
No, exactly. Well, you touched on historical data, and historical data is also obviously integral when it comes to starting your predictive maintenance journey.
Yeah.
So how does that look for you?
I'm not a massive fan, because one of the things that the system will do is learn what is normal very quickly.
Yeah.
Within 48 hours of data coming in, we have a normal baseline. So if a customer has a lot of historical data, it's only really interesting if they have machine failures within that we can learn from.
Okay.
If they've got a lot of data of their machines behaving normally, then there's not a whole lot of value to add that to a project, because we're going to learn what's normal in a couple of days anyway. So the only time really historic data is useful is, like I say, if you've got an interesting failure in that data, or sometimes when we're onboarding machines, if they're onboarded in a failing state, then that can be really useful. So, but most machines, if they're in a failing state, the data is going to get worse anyway. So often the historic side of it can be a big data exercise. It can take a lot of people's time to put data into the cloud, chug the algorithms over. It is obviously automatic, but the actual getting the data there, often from the customer side, is quite a big task.
Yeah.
And all you're doing is learning what normal looks like for these machines. And we can do that in 2 days anyway.
Exactly.
So I'm not a massive fan unless there's something interesting there.
Okay.
So I mean, often customers during the sales cycle will give some data and say, see if you can see where the issues are. But sometimes the data's not that interesting, and it can be a little bit of you have to do maybe some data filtering and things like that to pull out the interesting parts of the data. I remember the last time we did this, quite a big sales exercise from our colleagues in America, and they went into the customers to ditch a big presentation of, we saw this and blah, blah, blah. And when they got to the people at the site, it's like, but our machines don't fail in that way. It's like, so the data that's been given from a different site, but from the data they've been given, did have issues in it, but it's like, but that's not an issue for us. And that's part of our process of trying to get the right people in the room at the start of the project to decide, what are your problems, what are your machines that are giving you those problems, and how are you going to tackle it, what data is going to help you tackle it.
Yeah.
The reason we go through that is so we hopefully get buy-in from that particular site, and not just someone from head office saying, we're going to do this now. We really need buy-in from the site because they're the ones who are going to use the system. They're the ones who are going to make it a success.
Yeah.
And if they want to ignore the system, it doesn't matter how many alerts you're getting if people are ignoring their emails or not logging into the application. So we need those people on board from an early stage and asking them, what do these machines mean to you? What data would you like from them? I mean, sometimes obviously there's not data available, but start of the project, we want some senior management just to give us what we're going to measure. And then you want the people who know the machines to say, these machines have these problems. And then you have maybe the IT people and the OT people to come in and say what data you can get from them.
Yep.
And then it might be a case of, if you want to measure that, you need to have these particular sensors.
Yeah.
Not always, but sometimes, yeah.
Yeah, exactly. And I feel like when it does come to historical data, there are pros and cons. Mm-hmm. So you mentioned, sometimes maybe the data can be beneficial to give an understanding of maybe how the data's been in the past, or just to understand key trends and what the issues are. But then on the flip side, it could also be unreliable. So I think the good thing is once you have Senseye monitoring the assets, that takes a couple of days for it to churn through, so you can start to see the trends and patterns.
Yep.
So I think it's that, like I said, pros and cons. It gives maybe a good understanding of, what the data is and what we're kind of dealing with. But then, like I said, it takes time for the data to churn through. So once you start to monitor those assets, you can really understand, what's going on.
Yeah, and we are a real-time application, so we want to get users' feedback to changes in the data, alerts from the system, and we want to get that feedback from the user because that feedback is as important as the sensor data in the first place. So you don't tend to get that much user feedback from historic data because they know what's happened, and they're like, that was an issue and that wasn't. So I'm not a massive fan, but sometimes it can be fun. We did onboard one customer with 3 months of historic data for all their machines, and we were chugging through 66 years of data a day to try and get all this stuff through. So that was pretty good. Yeah. But that was only for about a couple of weeks. So I was asked how fast can you onboard stuff? I'm like, I'll have a look. And that's the biggest spike. And that was years ago. And now we're even faster at data processing. Yeah. So it's if the customer's got the data to send us, we can look at it, but if there's nothing interesting there, it's not going to be very interesting.
No, exactly.
And that's what we want interesting. Well, actually, no, we actually want quite a dull data set because then nothing's failing. Yeah. And we want to have, this is why in the previous podcast, I always talk about for the initial pilot, how many machines do you want to monitor? Because if you've got a customer who says, I'm going to monitor 10 motors, the likelihood of one of those failing in the next year is pretty slim. Yeah. Whereas if you've got a few thousand, then the likelihood of you seeing something interesting is definitely a lot more. So if you've got historic data and it's got interesting things in it, then very happy. But if it's just this is normal, then there's not a lot of point. Yeah,
exactly. I think it's having both the contextual data and the historical data. Each have their own, benefits of what they bring. Yeah. But if you could just do like a quick recap on those two, what would be your kind of takeaways around those types of data?
Well, like I say, I think we want data that actually means something to the maintainer who's looking at the application. So one of the nastiest data sets I had a lot of success with, and that was it was like a trolley. So it didn't have a motor or whatever on it. It's a trolley, 4 wheels, and it would get pushed by a motor and just scoot around the factory. There was about 400 of them. They didn't get used every time. They didn't sort of filter around and go to the back. Sometimes the trolley would disappear out of the production for a couple of weeks, and it would come back, and they took one measurement per pass around the factory. Okay. And they used to basically lift the trolley on one side and on the other side and measure with a visual sensor what the distance was, and it was measuring basically the movement in the bearings. So customer, we've got all of these, and if it goes above, I can't remember the actual value now, but if it goes above like 2 millimeters or whatever it is, then I want to know. So set it up, had thresholds, 2. Things were whizzing round, and there were quite a few of them above this threshold they set. And they're like, you know what? If it's above 2 for 4 times out of the last 10, then tell us about it. So we move. Thresholds are one of the easiest things you can set up in predictive maintenance. So take off the threshold and then put in a rule. So it looks at the data, it counts how many times it's broken that threshold in the last period of time. Okay. And then, so that reduced the list. And so they like that. And then when we brought out the derived measures functionality, I thought, well, what I'll do is I will count in the last month how many times it has crossed this threshold and make a new measure that's just slowly trending up, and then they can either put a threshold, if it's above 10 times in the last month, or 20 times, no matter. But we can use our fleet analytics to look at all of these trolleys, see which ones are leaning the most.
Okay.
And so that's how we ended up. They used to call it the leanometer. And it's the data was nasty because it was spiky. It was unreliable because often the sensor got dirty. So you'd have a run of too many spikes. But then because we could take what that data meant to those maintainers and put it into the application, then we could just enhance their maintenance strategy. So then when they had the time, they would just pick the 2 or 3 that were the wonkiest, and maintain those, and let the others just run around with their leanometers. So I think I've gone off on a bit of a tangent.
No, it's fine. But sorry to interrupt, Pete. I just wanted to, you touched on derived measures.
Yes.
So this is the functionality within the Senseye platform. Could you give a little bit more information just for our audience, just to understand what that is and what that means exactly?
So it was probably envisaged to be a little bit like edge processing, but within the cloud. So the data will arrive to the cloud, and then you can manipulate it before the analytics are run on it, and you can make new measures. And those measures are then run through our algorithms. So I think it was envisaged for things like if you've got a pressure drop across a pump, you could have 2 pressure measurements, and you could measure that within Senseye. So instead of doing it at the edge and sending the pressure differential to Senseye, you could do it within the application. So that's, I think, why it was designed. And it was just a way to help the customers, particularly the customers who didn't have the equipment and the technical expertise to manipulate the data at the edge before sending condition indicator data into the application. What it has turned into is just the most amazing device available, and customers are using it for all sorts. And so you take data in, and then you can just do mathematical functions on it, and you can put data out the other end. So one of the first times I really used it in anger was for a customer who was smelting aluminium, and they had a lot of these great big pots with, you get a crust of alumina on the top of these things, and they have some pokey things that press down to break it called cross breakers. And 4 of them on a pot, boom, boom, boom. And if the crust is too thick and the pokey thing takes too long, then it can start to melt. They can have problems there. If the pot isn't full enough, they can have issues. So the customer said to me that they were spending 20 hours a week making sure that the cross breakers are activating. I thought, that sounds crazy. But the data isn't suitable for anomaly detection, trend detection, that sort of thing. Let's have a look. So very simple derived measure set up to make sure that these 4 cross breakers were working, and then coming up with how effective they were being. This is great. But then they said, the trouble is, if one of the cross breakers is not working, we don't take it out of operation. So then I had to put in another bit of algorithm. So if cross breaker 1 was working, or was not working, but this particular bit of contextual data told me that, cross breaker 1 isn't working today, then that gets removed from the calculation and all that sort of stuff. So then, so it's very simple, 4 things in, 1 thing out, measure turned into like a big mind map of data. Really confusing, but really effective. And then we just started to add other things, and they started to enhance their production process because they had a better feel for how long the cross breakers were working. So then they started to increase the time that they would give the cross breakers to actually break, and they were monitoring that. And so it's a very fascinating, slightly off of topic for why this thing was designed, but you can just do a load of maths in it now. And so customers do all sorts of stuff.
Yeah.
The other one I had a bit of success with recently was a customer who performs maintenance activities based on the cycle count from their machines, and that quite often breaks, and they don't realize, so the cycle count will stay level and they hadn't realized. So as a bit of a side project, we're like, well, we will have a look at that. But the problem with that is that I can't just say, well, if it hasn't changed for a week, for example, because sometimes they'll Christmas shutdowns and things like that, they might not actually be in production. So we have to make a bit of a calculation where certain things are happening, but basically we're looking at, is this thing updating? And we left it running for a little while, and then all of a sudden this alarm went off in the system, like, oh, that's interesting, have you seen that? And the database had filled up again. So it's like, no. So all of the cycle counts in the entire factory were not updating. And so all of the maintenance that would have been performed on that wouldn't have been performed until somebody had noticed. And who knows how long it would take, a week or,
Yeah.
Maybe it's like, hang on a minute, we haven't maintained these things. They're like, So, but it's just, again, random. That is definitely contextual data from the customer, but it means something to them. And so we can put it into the application and just alert on it accordingly.
Yeah.
Which then makes it pretty much, you can do, I was going to say anything. There's always customers are coming in with, oh, can you do this? And can you add this block and that block? And it's like, so it's becoming massive, but it's really good, because if you can get the right data with the right ideas behind it, and then what would you like to be told about, then you can put it in, and then you get new data that goes into the algorithms. So often it's just customers use it for, like I said before, like off-state monitoring. So they can just send data. Doesn't matter whether the line's running or not running. They can have an on signal, and then everything just gets filtered for, okay, it's not running, so don't run any analytics. And it makes life on the customer side a lot easier. Although ideally they'd be doing that at the edge, and they wouldn't be sending us lots of off data because it's meaningless stuff.
Yeah, exactly. It's a great function on the app. I think it's a really, really great enhancement.
Yeah.
And a lot of customers have seen a lot of successes with it. It's like a different way to look at your data and go into it. Again, this whole topic of data. And like I say, it's what it means to the customer. And that's, so I've done a lot of, so there's a lot of very simple things you can do. Like I mentioned earlier, I don't really like temperature as a condition indicator type measurement, but you can normalize your temperature by taking the ambient temperature, and that's really handy if you want to monitor the temperature of your machines, because especially if stuff's up in the roof and it gets hot for a couple of weeks, people are like, I'm getting too many alarms here. So you go, well, you've got your ambient temperature, you can remove that, and then you can get a more consistent measurement that will tell you something about when your machine is actually overheating and not just it's getting warm in here. Okay, Pete. So what I wanted to move on to are, the main issues that customers have when it comes to their data and the quality. Yeah. Quality seems to be one of the maybe issues that they do encounter.
Yeah, I think so. I think still, surprisingly, customers sending data when the machines are off, and we have lots of ways for them to tell the system that don't monitor this stuff. But if they don't do it, the system will carry on monitoring. So often it's things like I have a non-production day and forget to tell the system. Or some customers find it hard to get reliable data for off-state filtering and things like that. So sometimes they just don't have a signal for their production line.
Yeah.
So the different bits of machinery will run independently. So that's it's very easy to solve, what seems to me easy to solve, but it's one area where customers will have the occasional false alert because the machine is just not doing what it normally does, but you're still sending data as if it should be. So that's one of them. And then I feel that different processes can have an impact. Sometimes we have some customers say, oh yeah, we'll we need to know these products being produced because it'll have a big impact. And then when you look at the data, different products don't make any difference.
Okay.
Sometimes, like I say, they think they should do and they don't. And then possibly how they sample. Sometimes customers will just like to send data every period of time, whether the machine's been on or not. So that can be a bit of an issue.
Okay.
Some customers like to send data that's easy to collect as opposed to data that is overly meaningful. But that can be somewhat annoying, but you have to live with it. And then, data that just, I suppose, changes randomly, that doesn't, where the maintainer doesn't need to know about it. So sometimes when we get data in, we will turn off certain analytics just because that data changes. I was going to say randomly, but not necessarily randomly, but because the data changes and that change isn't important to the machine condition. Often, again, with that contextual data, they might send that in and we won't run analytics over it, but it's there. So if things are changing on the machine, they can say, oh yeah, I can see why that's changing without having to actually go and investigate. So sometimes it's perhaps having analytics set on data that is going to change, and I look at the data that, I understand why the algorithm flagged that because it has moved quite significantly away from where your normal was, and the user's like, but it does it every third Tuesday of the month or whatever. Okay, well, in that case, we need to know when that Tuesday is going to be like, this week it was a Thursday.
It's changed.
Yeah.
Yeah. See, this is it. I think it is very much case by case.
Mm-hmm.
Each customer, there could be different issues which do occur and get picked up.
Yeah.
But the good thing is, I think 9 times out of 10, there always seems to be a solution.
Definitely, yeah.
And there's always a way to measure and understand why that's happening.
Mm-hmm.
Have you ever had any issue, or just from your experience, that customer experience, where you've had an issue and it's been very difficult to solve, or just trying to understand?
Yeah, I think my favourite one was, and I've now seen it twice, but a customer, a substation got hit by lightning, the direct current started to oscillate. So that AC current oscillates all the time. Direct current is meant to be flat, and their direct current was oscillating. And we picked it up on a number of different machines across different areas of their plant. And that was really odd. That took about 3 weeks for them to investigate and add additional sensing because they weren't sure why this direct current was changing like that. So, And then I liked it because, so when we go through the asset discovery side of things and what are your failure mode, what would the data look like, what we're going to monitor, but this, nobody had ever thought that this could happen. It's like the data changing and flagging it to the users and like, oh, let's go and have a look. So it's like one of the beauties of Senseye and looking at this at scale. And obviously it saved customers millions when they realized that the substation was faulty, because that would have, changing that, if it could have caused a lot of damage, obviously, but changing that out during production would have cost them a fortune. So, and also the direct current going too high and that sort of thing, that could also have damaged a lot of equipment. So there's potentially millions of dollars saved. But you can't say to customers, oh, look, you can monitor this, because then a few years ago, a colleague in Germany was like, has anybody ever detected substation being hit because one of the customers is like, whoa. So I've been here, let's say 7 years, and I've seen it twice. So I wouldn't necessarily say to customers, all right, you've got to monitor for this because it could happen.
Yeah.
But you think of all the factories we have access to over those 7 years. I've only seen it twice, but that's, really funky data changes. And I've got quite a good one on the boil today. My first meeting this morning with a customer, and they're scrubbing gas out of their, or the nasty gas out of their facilities, and their data started, funnily enough, to behave a little bit like the previous issue I was talking about, and that's taking a little bit of investigating, because the oven temperature is fluctuating and some of the elements are not producing power, and they didn't get an error in the PLC. So that's currently being investigated. So I'm like, oh, this is going to be interesting.
Exciting. I feel like, I think it must be exciting for you to sometimes, have these issues which pop up, but understanding, there could be various different reasons as to why this is happening. And it's probably this feeling of accomplishment. I think that's what it is. Once you've resolved what the issue is, when they do pop up, like it's a bit of a mystery.
Definitely. And so my background, I started off as a mechanical engineering apprentice, and I worked for a company that made machines.
Okay.
And that was interesting. Tootled off to university and then ended up in the oil industry. And then I ended up there so after being a field engineer, being in technical support, and then looking after when things started to go wrong, and trying to troubleshoot and doing it remotely as well. So most of that part of my career, I was in Africa when we had no internet connectivity to the rigs at the time and stuff like that. So trying to troubleshoot over radios at first, and then cell phones, and maybe getting screenshots, so all of that sort of stuff. So now when I see these issues occurring, but we're getting to them before it's caused the customer the actual aggravation, that's what I love about it. And that's when I first saw our colleague Alex present a few years ago, and like, this is what Senseye is all about. And I'm like, wow, that's amazing. I'd love to be a part of that. So then joined them after 6 months, 9 months, whenever long it was. I was having to harass them to employ me, and it is fascinating. Yes. And it's because dealing with all sorts of people all over the world, all sorts of machines, but it's that one goal of helping people avoid the stress and my plant's down and it's on me to get it up and running. Because I've had enough of that in my life. I like the easy life now of like, oh, we ought to look at that before it goes wrong. So and we do it by this wonderful data stream that customers can just pull information off, send it to us. It gets mixed about in a cloud, and then the warnings come out. It's brilliant.
It is very brilliant. And I think this is what it is. Like the potential is huge. Like we touched on assets and different asset types and different industries. So it's not just fixed to one industry, but it's interesting, even talking to other colleagues around different asset types, just to understand that, which is fantastic. And even from my perspective, it's always knowledge. We've got automotive industry, we've got oil and gas, you've got the pharma industry, but each one has their own assets, and there is maybe this element of crossover, but I feel like the beauty of it is the fact that each customer has a different story. And each customer, measures that their assets are measured in a different way, but the ultimate goal is to reduce downtime, improve efficiency, maybe also just having that educational piece. So, individuals, like I said, about human interaction, they actually have more understanding of why the machines are failing. So it's this whole kind of like coming together, which is really nice. And, we've seen a lot of successes with a lot of our customers across the world.
And with the introduction of Copilot now, that's having an impact on the customers, because they can now see that if they give a little bit more into the application, then it will give back more details to them. So that's really nice. So obviously that's been rolled out in the last year or so, and it's quite interesting to see people use it. And also when the Copilot suggests things like, oh, I'll copy and paste that in the work order to the maintainers because they're going to think I'm really smart if I figured this out.
Yeah.
And then, like I say, then they give more details to the system, and then next time it sees a similar thing. Oh, last time you did this. We had quite an interesting one when somebody was asking me about getting successes for Copilot when I was looking through one of our more mature customers, and the Copilot basically said, look, you've done this the last 3 times, it hasn't fixed it. It was a bit more diplomatic than that, but that really made me giggle. I was like, are you sure you're actually doing this? It's a lubrication thing. And their automatic lubrication had failed. And I was like, So yeah, but you've had this issue 3 times, what you've done hasn't fixed it. You need to look at other things.
Yeah.
That's interesting. Also, now we talk about data, we're now able to upload manuals and work order procedures and all that sort of stuff to help guide the users and to help to speed up the learnings of newer employees as opposed to someone as old as me who's got all the experience of, oh yeah, I've seen that before when it might have been 10, 15 years ago.
Yeah. Well, that's it. I feel like this is the data evolves.
Definitely.
If we look back maybe 20, 30 years ago to now, we've got all of these, now we live in a digital world. So we've got AI, and you mentioned around the Senseye Copilot. Yep. So having that, function available in the platform is amazing.
Mm-hmm.
And I think just touching on that, I feel like customers feel more comfortable talking to this chat bot that we have within the platform.
Definitely.
And it simplifies a lot of questions that they might have.
Yeah.
So I think that's the beauty of the platform that we have. There's, human interaction is needed and having that support, but also being able to ask the questions that you are unsure about.
Mm-hmm.
So it all comes together.
Yeah, definitely. And as you mentioned, they're more likely to ask, the expression, there's no such thing as a silly question.
Yeah.
But people, I don't want to say, I just don't understand what that means.
Yeah.
But that's probably the most important question to ask. It's like, I don't actually understand what is this data. And in the past, one particular project we worked on, really complicated machine, and the project was quite successful. But when it came down to the last bit of implementing it, the users didn't know what the data meant. And so having to, this means you have to maintain that bit.
Yeah.
That was a manual task to explain all that, whereas now the Copilot is like, it could be this, could be that. It's, again, automated there at your fingertips. So, it's surprising.
But there's no silly question.
No.
I mean, the funny thing is, just from my perspective, just personal experience, but I've used ChatGPT and sometimes you do ask questions that you might not be sure about, and it's fantastic.
Yeah.
And, I have seen it become, like a best friend, essentially. So, within the Senseye platform, you do have your best friend to help you manage your data.
Yeah. Yeah, I think, again, we're just beginning to scratch the next part of that, of what customers can do by uploading documentation and to streamline their maintenance through that as well. So it's always exciting times.
Yeah. And how can companies overcome data silos between IT and OT systems?
I think they have to be careful about the products that they actually invest in, because there are plenty of particularly predictive maintenance, vibration-y type sensors where you can get those sensors and they will provide data to one particular application. And so that's fine if you want to monitor vibration, but then if you want to take in some of that contextual information or some of the OT information, if that system doesn't actually accept it, then you're going to be a little bit snookered there. So definitely you want to look at companies that are a little bit more open with the data and how they share it. Obviously, I would be a big advocate of Senseye Predictive Maintenance because we've been data source agnostic for years.
Yeah.
But what we have found is that the lots of bits of, we used to call it the Internet of Things, can talk to other applications, but there always needs to be something in the middle that will do the translation, because one product will be talking in one language, and so you need to have that link to get the data from one application to the next. So we've got who we call Senseye Ready products, and so those will be particular sensing products and different like data historian, CMMS systems, things like that can send data to us directly. Okay. So that definitely helps to reduce silos, because you can have your data from the different silos accessible by the one application. Okay. So that's quite important. And I also feel that when you start to look at, like I say, the meaningfulness of different things, being able to sample it in a way that you can then send it to a system like Senseye is really useful. There are certain, I haven't seen them for a long time, but we did have, there used to be some quite useless vibration sensors on the market. So I would definitely advise customers to look at the quality of any sensing that they might be looking to choose. Okay. I'm not saying everything has to be the highest grade, because sometimes you just want a simple vibration measurement on something that you say, oh, it's increasing. You can go and investigate it, as opposed to sometimes you want to have a high-end sensor that when you have it on the machine, it can tell you, oh, yeah, it's that part of that bearing that's failing. So that depends on the application for the customer.
Yeah. And do you feel like it, I think one question that I've got that I'm interested to get your opinion on, can you still succeed with your predictive maintenance if the data isn't perfect?
Yes, as long as you know what you want to monitor out of that data, I would suggest. There has to be a reason behind whatever it is you've chosen, and not just lots of temperature sensors. They're very easy to get data out of, but man, they're noisy. Just because temperature kind of varies randomly. If you're off for the weekend, your machine will cool down, or if you've producing over for a couple of weeks, it might be hotter. It could be hot outside. Anyway, I will stop ranting about temperature. But so customer, if the data has signatures, elements in it that mean something to them, we can pull it out, we can alert them on those things. Okay. If it's just a case of this machine has data, I will send it to an application, you might not get as much success out of that. It needs to be, you need to have a reason for what you're monitoring. Okay.
And for anyone starting up in terms of their predictive maintenance journey, what best practices would you give for the foundations?
Yeah, I think the way that we operate of getting, say, the right people in the room at the start of the project, so people understand what they're trying to improve, and then getting the machines that can help them to improve that. I think that is super critical, because if you don't have alignment on that, then I don't think the project will go very well to begin with. We do like to have the IT/OT people and the expert on the machine talking to each other as well, because we need to make sure that the user is getting the data that they actually want. Okay. And if they're not, then you're not going to have that much success. We've had a number of projects where customers have said, no, we haven't seen anything yet. And then we say, well, have any of these machines failed? Like, no, we don't have a problem with these machines. You're like, okay, but then how are we going to predictive maintenance if there aren't any issues on these machines? So part of that is, well, then you need to start to reduce perhaps the maintenance that you are doing to these machines. Yeah. And that can be a little bit scary for customers if they haven't had the full buy-in from the start. So I would definitely want customers to choose their problem children from a machine point of view to start with, something that will have issues and be able to talk about what the issues are and what data they think will show that. That's, for me, number one. And as I often say, make sure you've got enough of them that you have a chance of failure, because we have customers, their machine, maybe 2% of them fail each year. Other customers, and it's not across the board, but the thing that they interact with the most is about 12% a year. And so if you look at that as am I going to see success doing this? You need to have the enough machines in there to see that. Now, if you're looking for more of a data visualization type approach, that can be fine, but everybody has to be aligned with that at the beginning of the project. It's okay, we're going to spend a couple of months hooking up our IT/OT infrastructure, getting the data to you, and then we will be able to visualize. You're like, yeah, that's fine, but once you visualize, what you're going to do with it, and where will the success come from? That you need to have that in your mind at the beginning, because if not, you get a few months into a project and you're like, well, why are we doing this? If it's just that we're going to hook up a load of temperature sensors for you guys, it's not going to be great. I feel that you need alignment between the people paying for the project and the people who will make it successful, which are generally your maintainers or your maintenance planner, that sort of thing. If you have a head office down approach, then you might have cultural issues with the deployment, because if this is being forced on us and we don't really want to use it, that can be a bit of an issue. People are suspicious of improvements, particularly when they think, AI is coming in to replace us. And people will not embrace the technology if they think the only reason it's being purchased is to try and make them redundant. So they will not be overly helpful in the rollout and actually learning how to use the system and feeding the data into the system to improve it. So the cultural side of it is probably much of a stronger point than any of the data sides of it.
I was going to just touch on that. So the cultural side is very integral. And there's often this assumption which is made around, AI and this, just generally speaking, around, platforms replacing human interaction and individuals' jobs. So this whole talk around redundancies. But I think it's also taken into account that's not the case. We still need human interaction. We do have this, which can support you and improve efficiency within your organization. But this is often something that does come up around cultural elements. And maybe that's why, there can be this element of hesitation. But that's one point that you raise, which does come up.
And I feel that, from the Senseye Predictive Maintenance point of view, we are not in the business of replacing humans. What we are in the business of doing is making the humans be able to plan their interactions more effectively and to take some of the repetitive, more boring tasks out of their lives, so they're not having to go around and check their machines all the time. They can have their most critical machines just running nicely, and they can go on with other more interesting tasks. We do have lots of customers will still like to walk around their machines, just because you get that feel of what's going on in the production line. But I think I said it in our last podcast when one of my colleagues was talking to a director from one of our initial customers, and after the initial deployment, he was saying the funny thing was, just walking around, everybody was calmer, people were more productive, the atmosphere was nicer. It's just having Senseye there just makes for a better maintenance strategy, happier people, and I think I said last time, who wouldn't want to work for an organisation that can do that, deliver happiness and try and reduce some of that stress from the maintainers in the world are often put under a lot of pressure, and they anything we can do to help to relieve that burden and make their life easier. I am a big fan of.
Yeah, exactly.
I've had enough angry, particularly in the oil industry, the company man shouting at me because the thing had failed. It's like, I'm just doing my best to fix it.
Well, that's it. I think that's the bonus as well with what we have as a solution. We've got a great team of individuals which can really, really support. And like I said, successes vary. Like each customer is different. And touching back into, like I said, the different industries that we cover and work in. So it's always lovely to see when customers have these successes and they can, maybe do a song and dance about it, which is really nice because, like I said, it comes back to, reducing downtime, improving efficiency, also just having that interaction of teams working together because when it does come to deploying predictive maintenance, it's also ensuring all stakeholders are on board. So I feel like that's a really important point to mention because it's not just a solution, it's just ensuring that everything comes together. So you can actually monitor and understand what's going to work and what's going to be the most effective solution for you. So,
yes, definitely. The cultural part of it is the most critical. And celebrating successes, particularly internally, get the maintainers to shout about it because they've saved their company a lot of money, and they should make sure that the company is aware of that and that they are celebrated for it as well. And it's nice as well. We often see particular critical users at the beginning of a project end up getting promoted, and often it's sad to see them leave the project, and then a year or so later they come back as a boss. It's like, well, hey, you're back, this is good. And it's like, we've got somebody who's going to help drive this within their organisation. It's really fun to be involved in that sort of thing.
Yeah, no, exactly. So just coming to the end of this session, which has been very, very insightful, Pete, just wanted to know if you had any final thoughts, any final pieces of advice or key takeaways that we could give our audience today around this, the importance of data when it does come to a predictive maintenance strategy.
So I think the first thing is definitely start your journey. It's never too late to start, and all your competitors will be doing it. So you need to join in. And then definitely, I can't emphasize enough about the cultural approach and the trying to get the buy-in from the different areas of the organization, and then getting the right people in the room to discuss the machines and the failure modes and the data, and then operate and use it, give feedback to the system, and look at whatever you're going to add next. And then after that.
Exactly.
And hopefully we'll have a beautiful relationship for the next 5 years or more as you are just adding more and more stuff. Like, this was really cool.
Well, you mentioned around scaling. So that's really interesting because a lot of customers now are utilizing that and they've got that option to scale their deployments, which is fantastic. So like I said, you could start off, we've seen customers who have started off with few assets and now they've got thousands of assets which are being monitored. So it's a journey that everyone has. And like you mentioned as well, like the successes of our customers, it's really fulfilling from our perspective to, hear about all those lovely stories and how we've made it easier for them with their deployments of predictive maintenance. So yeah, fantastic. Well, thank you so much, Pete, for joining me on today's episode. Please like and subscribe on all podcast channels, and you can find out more about Senseye Predictive Maintenance at Siemens.com.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.